Hello, knowledge seekers. In this video, we will solve a conditional probability problem. And more importantly, we will look at the logic behind the formula that is used to solve such conditional probability questions. Now, it's easy to remember the formula and apply it. It's a pretty straightforward process, but understanding the intuition or the logic behind the formula helps you internalize the formula so that you never forget it. So let's start. So the question is pretty simple. A doctor visits a sick child in a neighborhood where 90% of the kids have the flu, 10% have the measles. Measles often causes a rash with a 95% probability, while flu causes a rash with 8% probability. If the doctor finds a rash on the child, what is the probability that the child has measles? So let's take an example. Let's say the sample space, the number of sick kids in the neighborhood is 1,000. So there are 1,000 sick kids. All right. So there are 1,000 sick kids. Now, the probability of flu is 0.9. Now, this means 1,000 into 0.9, which is equal to 900. So, 900 kids have the flu. Now, probability of measles is 10%, which is 0.1. What this means is out of these 1,000 sick kids, 0.1 into 1,000 is equal to 100. 100 kids have measles. Now, probability of a rash given the kid has flu is 8% or 0.08, which means kids with rash who have flu is 900 into 0.08, which is 700 and or rather 72. Now, probability of a rash given measles is 0.95, which means the number of kids who have a rash and have measles is 100 into 0.95, which is equal to 95. So, our sample space is 72 plus 95, which is equal to 167. Favorable outcome is this 95. So probability that a rash was observed and the kid has measles, sorry, probability that the kid has measles given they have a rash is equal to 95 divided by 167, and this is the answer. Now, what is the formula? So, if we have to write a formula for finding such conditional probabilities, in the denominator, I want the population size, I want the sample space, the size of the sample space, or how many items are there in the sample space, which is probability of measles times probability of rash given measles plus probability of flu times probability of rash given flu. So this thing gives you this number, and this thing gives you this number. And in the numerator, we have the favorable outcome, which is the left part of the denominator, which is probability of measles times probability of a rash given measles. So we can write probability of measles given a rash was observed is this. Now you don't have to remember this because now you understand the logic. Now let's say a problem has a third disease. Let's say stomach flu, which has a probability of PS, which is let's say whatever. I mean, let's say if this is 0.85, then stomach flu is 0.05, and let's say probability of a rash given stomach flu is is 10%. So 0.01. Now you can modify this formula without even thinking because now you understand the logic. So you will say probability of stomach flu times probability of rash given stomach flu. And it doesn't matter how many diseases there are in the population. Now you understand the logic. I hope this explanation helped. And if you found this video useful, please give it a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.